Welcome to the first lecture of this course, PTSP, Probability Theory and Stochastic Process. The first lecture is Deterministic Model and Non-Deterministic Model. To understand in a better way, let us consider a simple resistive circuit having a resistor and the supply or battery. The supply voltage V is equals to 1 volt given here. The resistance R is equals to 1 kilo ohm. If you connect the circuit like this, obviously some sort of current will flow through this circuit. According to the Ohm's law, you can find the current I is equals to V by R. That is 1 volt by 1 into 10 to the power of 3. If it is coming this way, then it can be written as 1 into 10 to the power minus 3, nothing but 1 milliampere. So the current is 1 milliampere. So what we learn from this experiment is that whenever we conduct the experiment like this, we will get obviously 1 milliampere again and again and again. So if we repeat the above experiment number of times, each time we get the same value. By keeping the V and R constant, we will get the expected outcome. Okay, so this is called deterministic model. So deterministic model is a model which will be expect the outcome of an experiment. So deterministic model is a model which will be expect the desired outcome of an experiment. Here we can observe the what it will be the current value. Okay, so we can predict the value. So finally deterministic model is a model. So finally deterministic model is nothing but we can predict the expected outcome. Okay, under the same conditions. Now we will move on to the non-deterministic model. Consider the experiment as tossing a coin. The result of the experiment is either maybe the tail or head. So particularly in such type of experiments, we cannot ascertain or we cannot predict the value of certain variables, so that the results will vary from one performance of the experiment to the next performance. Most of the conditions maybe it will be the same and may not be the same. So those experiments as called non-deterministic model. So that means we cannot predict the expected outcome. The following features are pertinent for the characterization of a random experiment. The following features are related to characterization of a random experiment. First one is each experiment is capable of being repeatedly indefinitely under certain unchanged conditions. So every experiment is, so maybe each time it will be repeated. Each time it may be repeated. Second, we can't predict the outcome, but the possible conditions can be set out. We can describe the possible outcomes. Third point is, so by repeated times conducting the experiment, individual outcome seems to be haphazard manner. That means when we putting a toss here, so it may be a head, and if you conduct the experiment another time, it may be a tail or it may be a head again. So out of these 3 times, we got the 2 times head, and 1 time only we will get the tail. So these type of mathematical formulations can be described by conducting the experiment in repeated times. Otherwise, we cannot predict the expected outcome. These are the 3 important points we may find out. So the first one is each time the same output maybe it will come, and by conducting this experiment, we can describe some possible outcomes maybe, and the individual outcomes, when we observe that, it will be the haphazard manner. Haphazard means lacking an order. So we cannot get the things into the perfect order. Okay, it comes as it will be. These are the deterministic and non-deterministic models.